Okay, so when the question is asking you to factor, it's not going to tell you what factoring method you're going to have to use. You're going to have to decide what factoring method to use. There's questions that you're going to ask yourself, and always, always your first question is, do I have a common factor? No matter what you have, if a binomial, polynomial with 4 terms, 10 terms, whatever it is, the first question always, do I have a common factor? If you do, you must take that common factor out first and then proceed to your next question. Proceed to your next step, I mean. So, after you ask yourself if you have a common factor, and if you do, you factor it out, then you're going to have to make one of 2 decisions. Is it a binomial, so it's 2 terms? Then you're going to have to think about difference of squares. Remember, you must have a minus between them, right? If you have a binomial, so 2 terms, they have to be squared and a minus between them. Then you have to do the difference of squares. Then, if you don't have that and you have a trinomial, so 3 terms, you're going to have to think about the sum and product. Okay? So if you have something that looks like this, this is acting weird today. So plus 3x plus 2, for example, then you're going to have to think about the sum and product. So it depends on what you have, but the first question is always, always, do I have a common factor? So let's look at this example. So I have 3x squared plus 21x plus 36. The question is factor completely. So you're looking at this, how can you factor? Or what do you have to ask yourself first? Do you have a common factor? What is it? 3. No x's, right? Because this has an x, this has an x, this doesn't have an x, right? So x is not a common factor, it's just the number 3. Because I can divide 3 by 3, I can divide 21 by 3, I can divide 36 by 3. Okay, so 3 is my common factor. I'm going to just kind of show you how you can skip a step. If you put just this, so you see what's down, okay? You can just do this. So what's 3 over 3? 1x squared, right? 21 over 3, 7x. 36 over 3, 12. Okay? So I did my common factor out. Remember, you have to put your greatest common factor outside with your leftovers into your bracket. If you don't write that 3 here, would that be correct? No. They won't be equal to each other. Now, after I do my common factoring, I'm going to have to look at my leftover. Is my leftover a binomial or a trinomial? Trinomial. So I have to think about which method. The difference of squares or the sum and product? Sum and product, because it's a trinomial. 1, 2, 3 terms. So if I'm looking at the sum and product, I'm looking for 2 numbers that multiply to 12 and add to 7. So remember your multiplication. Multiply to C, so in this case multiply and add to 7. What multiplies to 12? 3 and 4? 12 and 1? 2 and 6? Right? In this case, they both are going to be positive because my B and C are both positive, so both my factors are going to be positive. What does 3 and 4 add to? 7. So did I find my answer? Yes. So it's 3 and 4. So my factors are 3 and 4. Okay? So I can right away write it as x plus 3, x plus 4. Done. It's fully factored. Does that? They're both pluses, yes, because if you look at this, both your B and your C, they're both positive, that means both your factors are positive. They have to be in brackets, yeah.
And does it matter if the brackets are switched around? Like,
Doesn't matter if you write it as 3x plus 4,
yeah,
x plus 3.
yeah, because I'm finding it easier.
Does that matter? No. Either answers are correct because it's multiplication. Multiplication is, it doesn't matter which order you write it in. Are we okay with this? Good. Now, if you don't have a common factor, do you have to factor a 1 out? No. Okay, don't waste your time with this step. Okay. How about B? What do I do? Do I have a common factor? What is it? 2. So I can factor out a 2. If I divide this by 2 and divide this by 2, what do I get? X squared minus, 25. Okay, so I took my common factor out. Now I have to think about my brackets. Is it a binomial or a trinomial? Binomial are the difference of squares. Do I have two squared terms? Is there a minus between them? Yes. Good. So I can do difference of squares. My difference of squares have to be plus and minus. What do I put in the first? X, because the square root of x squared is x. What do I put in my second spot? 5, because the square root of 25 is 5. Are we okay with this?
So you said if it's binomial with a negative sign, then you have to square it.
That's right. So remember that the difference of squares, you must have two squared term. So I'm just going to give you an example here. So you must have two squared term with a minus between them. When you're factoring it out, you're going to put two brackets, a plus in the first one and a minus in the second one. And then you're going to do the square root of the first in the first position and the square root of the second in the second position. Right? So that gives you a plus b, a minus b. Okay? So there's two things that you need to check, is that your first term and your second term are both squared terms, either numbers or letters, as long as they're squared. So like the numbers 1, 4, 9, 16, 25, 36, 49, these numbers, right? The squared numbers. And then if it's a letter, what must it have? What kind of exponent? Even exponent.
It's going to be an quiz,
Not the mixed factoring, but it's either you have to do common factoring, sum and product, or difference of squares. Are we okay with this? Let's look at the third one. What's my first question? Do I have a common factor? Do you have a common factor? 4. Can you divide each term by 4? Yes. Good. So my common factor is 4. What do I get if I divide each term by 4? X squared minus 2x minus 15. My leftovers, binomial or trinomial? Trinomial, so that means I have to think about sum and product. Okay, I'm looking for two numbers that multiply to what and add to what? Guys, you have to be careful because you have to get, that's right. So you're looking for numbers that multiply to negative 15 and add to negative 2. Remember, B, C. B, C. So, get the green sheet. Both B and C are negative, so I'm looking at this one. Okay, so what multiplied to negative 15? What did we say? 3 and negative 5. Okay, what else multiplied to negative 15? Okay, 3 plus negative 5. What does that give me? Is that my answer? So I've already found my factors, right? So that is 4x plus 3, x minus 5. Now sometimes, if you do common factoring and then you try to find multiples that multiply to something and add to something and you don't have that, that means you can't factor it any further. That means you stop. Okay? So sometimes you get to this point and then you don't find numbers that multiply to C and add to B, then you don't have to do anything. You stop right there.
For the second one, x minus 5, but is minus 5 already minus 5?
No. It's whatever your numbers that you see there, they're going to go here. If it's a positive, it will be positive. If it's a negative, it will be negative. Whatever your factors are, whatever the numbers that you found, they go in the bracket. Okay? Same with this. Because these are both positive, then they both go positive.
Yes, but there is negative already there.
What do you mean there's already a negative?
And two brackets, you put one plus, the second one minus.
No,
right?
no. That's only if you're doing difference of squares. Don't mix yourself up. Okay? You put the plus and minus only for the difference of squares. Does that make sense to you guys? Okay. Typical word problems. So they give you the surface area of a cylinder is given by the formula SA equals, SA stands for surface area, equals 2 pi r squared plus 2 pi rh. R stands for radius, h stands for the height of the cylinder. Factor the expression of the surface area. So they want you to factor this. So if you're factoring this, what's the first question you're going to ask yourself? Do I have a common factor? Do you have a common factor? What is it? 2 pi r. Right? Both terms have the number 2. Both terms have the number or the symbol pi. Right? Both have the letter r. So I can have a greatest common factor of 2 pi r. Now, if I divide this by 2 pi r, and you divide this by 2 pi r, tell me what do you have left over? What do you have left overs in the first one? R, because the 2 and the 2 cancel, the pi and the pi cancel, and then when I have r squared over r, I'll be left only with r. Plus, what would be for my second term? H. 2 and 2 cancel, pi and pi cancel, r and r cancel, so I'll be left with h. Right? So my greatest common factor is 2 pi r, and then my leftover is r plus h. So it's 2 pi r times r plus h. Now a cylinder has a radius of 3 centimeter and a height of 10 centimeter. So they gave you the value of the radius and the value of the height. use both the original equation or expression and the factored expression to find the surface area of the cylinder to the nearest squared centimeter. So what do they want you to do? Plug in the values. So I'm going to use both formulas. So I'm going to write the formula here, which is my original one. And I'm going to do another one here for the factored one. So if I plug in 3 for R, 10 for H. So I will have 2 pi times 3 squared plus 2 pi times 3 times 10. Do you guys know where I'm getting the 3 and the 10 from? Yeah, because R is 3, H is 10. So I'm replacing R with a 3 and then H with a 10. Then if I'm going to do this, that's 2 pi times 9 plus 2 pi times 30. What's 2 pi times 9? 18 pi. 3 squared. What's 2 pi times 30? 60 pi. Right? So I'm doing 2 times 30, so that's 60 pi. And then I add them to give me 78 pi. I can leave it at 78 pi, or you can multiply 78 by pi and see what your answer is. But as of now, I don't have a calculator with me, so I'm doing it this way, and I'm leaving my answer to 78 pi centimeters squared.
Is this an okay way to write it on some kind of?
Yeah. This is the scientific way to write it.
So it's going to be 78 pi.
Yeah. So if you want to find the answer, actually on the calculator, you just do 78 times pi. Let's do the same thing with second calculator. So I have surface area equals to 2 pi times 3, and then multiplied by 3 plus 10.
Is it something like square?
Yep. Because surface area is anything that's area is squared. So what do you guys want to do in the first equation, in that equation where I replaced the R and the H? What does BudMath say I have to do? The brackets. So add inside the brackets. So surface area equals to 2 pi times 3 times 13. Right? Okay, now I have all multiplication. Can I do it all together? 2 times 3 is 6. 6 times 13 is 78. Pi. Done.
Does it matter which way you do it?
No, you're going to get the same answer. Now, which one is easier, though?
Probably that way.
The first one.
Second one is easier. Yeah. Second one's easier. You don't have as many numbers to replace, right? There's only like one addition and multiplication, right? The first one's a little bit more complicated. At the end of the day, you're going to get the same answer. Usually, it's the factored form are usually easier to evaluate if you don't have a calculator. Okay, so I'm not going to answer the last question. You guys can answer it. Why would the factored form of the formula be more useful than the original form? It's not more useful. It's just easier, right? It's just easier to compute without a calculator.
So what do you call these two forms again? These two ways of doing it?
So the first form is the standard form. The second one is the factored, because that's when we factored. So, or you can call this the expanded, right? And this is the factored.